Hello everyone, welcome back to our math lesson videos. For our lesson today, we will discuss about trigonometric ratios of special angles. So here's our lesson objectives. Recall the measurements of the angles in special right triangles. Calculate the value of the trigonometric ratios of special angles.
That's not all cute.
Compare the trigonometric ratios in complementary angles. Distinguish the relationship formed in cofunctions of complementary angles and solve expressions involving trigonometric ratios of special angles. So before we start with trigonometric ratios of special angles, let us recall the measurement of the legs and the angles of special right triangles. Let's start with the 30-60-90 right triangle. For the 30-60-90 right triangle, if the length of the shortest side is 1, the length of the longer side should be square root of 3. And the length of the hypotenuse is twice the length of the shorter side, therefore it will be 2. For a 45-45-90 right triangle, if the length of one leg is 1, the length of the other leg is also 1, and the length of the hypotenuse is square root of 2 times the length of the leg.
I'm really sorry.
Now let us get the trigonometric ratios of special angles: 30 degrees, 60 degrees, 45 degrees, 90 degrees, and 0 degree.
This is all my fault.
Let's start with
It's only good for one thing now. Destroying
the 30-degree angle. From our previous lesson, we learned that the trigonometric ratios are the comparison of the sides of a right triangle, whereas sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Also, we were able to learn about the reciprocal trigonometric ratios. The reciprocal of sine is cosecant. Therefore, it is hypotenuse divided by the opposite side. While the reciprocal of cosine is secant. Therefore, it is hypotenuse divided by the adjacent side. And the reciprocal of tangent is cotangent. Therefore, it is adjacent over the opposite side. We are not going to use calculator for our lesson today, and we are going to express our answers in their radical form. In our example, the 30-degree angle is located here, and opposite the 30-degree angle is side whose measurement is 1. The side adjacent to our 30-degree angle is square root of 3. And the hypotenuse is 2. From our last video, we have learned that regardless of the length of the sides of a right triangle, the trigonometric ratios of our angles are always the same. Now, let us get the trigonometric ratios with respect to 30 degrees. So, let's start with getting the sine of 30 degrees. So, we know that sine is opposite side over the hypotenuse. Therefore, it's 1 divided by the hypotenuse, 2. And that's it. Now, when we get the cosine of 30 degrees, we know that it's adjacent over hypotenuse. Therefore, it's square root of 3 divided by 2. Now, when we get the tangent of 30 degrees, that is opposite side over the adjacent side. Therefore, it is 1 over the square root of 3. And we need to rationalize the denominator of tangent 30. So we multiply both sides by the denominator square root of 3. 1 times square root of 3 is square root of 3, while square root of 3 times square root of 3 is 3. Now, let us solve the reciprocal trigonometric ratios. So, the reciprocal of sine is cosecant. Therefore, it is hypotenuse over opposite side, which is 2 divided by 1, and 2 divided by 1 is equal to 2. The reciprocal of cosine is secant. So, it's hypotenuse divided by the adjacent side. So, it will be 2 over square root of 3. And again, we have to rationalize the denominator by multiplying both sides by square root of 3. So, secant is 2 times square root of 3, which is 2 square root of 3 all over square root of 3 times square root of 3, which is 3. And cotangent is adjacent over opposite side. So, it is square root of 3 divided by 1 or square root of 3. So, sine 30 degrees is 1/2. Cosine 30 degrees is square root of 3 over 2. Tangent 30 degrees is square root of 3 over 3. Cotangent 30 degrees is square root of 3. Secant 30 degrees is 2 square root of 3 over 3. And cosecant 30 degrees is 2. Now, let us move to our 60-degree angle. In the same triangle, the 60-degree angle is opposite the 30 degrees. And we can say that 60 degrees is the complement of 30 degrees. Now, let us identify the sides with respect to 60 degrees. The side opposite 60 degrees measures square root of 3. The side adjacent to 60 degrees measures 1. And the hypotenuse of the triangle is 2. Now, let us get the 6 trigonometric ratios of 60-degree angle. Start off with sine 60 degrees. Again, sine is opposite over hypotenuse. Therefore, sine 60 degrees is square root of 3 divided by the hypotenuse, which is 2. Now, to get cosine 60 degrees, we have to divide the adjacent side by the hypotenuse. Therefore, cosine 60 degrees is 1/2. Now, let us get tangent 60 degrees, which is opposite over adjacent. Opposite side is square root of 3, and the adjacent side is 1. To simplify, this is simply square root of 3. Now, let us get the reciprocal ratios. The reciprocal of sine is cosecant. So, if sine is opposite over hypotenuse, cosecant is hypotenuse over the opposite side. So, we have 2 divided by square root of 3. We have to rationalize the denominator square root of 3 by multiplying both sides by square root of 3. Cosecant is equal to 2 square root of 3 divided by 3. Now, let us go to secant, which is the reciprocal of cosine. So, secant is hypotenuse divided by the adjacent side. So, that is 2 over 1. Therefore, this is 2. Now, let us go to cotangent 60 degrees, which is the reciprocal of tangent. If tangent is opposite side over adjacent side, cotangent is adjacent side divided by the opposite side. Therefore, it is 1 over the square root of 3. Again, we have to rationalize our denominator by multiplying both sides by square root of 3. 1 times square root of 3 is square root of 3, and square root of 3 times square root of 3 is 3. So, the cotangent of 60 degrees is square root of 3. If you can remember, sine of 30 degrees is 1/2, and the cosine of 30 degrees is square root of 3 over 2. Now, for 60-degree angle, the values are interchanged. Tangent of 30 degrees is square root of 3 over 3, while the cotangent is square root of 3. So, for 60 degrees, the values are also interchanged. Again, secant 30 degrees is 2 square root of 3 over 3. Cosecant 30 degrees is 2. For 60 degrees, the values are interchanged. That is because 30 degrees and 60 degrees are complementary angles. And if you can remember from our last video, the cofunctions of complementary angles are equal. So here, sine 30 degrees is equal to the sine of 60 degrees, while cosine 30 degrees is equal to sine 60 degrees. Tangent 30 degrees is equal to cotangent 60 degrees. Cotangent 30 degrees is equal to tangent 60 degrees. Secant 30 degrees is equal to cosecant 60 degrees. And cosecant 30 degrees is equal to secant 60 degrees. Now, let us get the trigonometric ratios of a 45, 45, 90 right triangle. So, the base angles are both 45 degrees. We can use either of the acute angles because it is both 45 degrees and the measurements are the same. The opposite side, so when we get the opposite side of the 45 degrees, the measure is 1. The adjacent side is also 1, and the hypotenuse is square root of 2. Now, let us get the trigonometric ratios. Again, sine is opposite over hypotenuse. Therefore, sine 45 degrees is equal to opposite, which is 1, and the hypotenuse, which is square root of 2. Now, let us rationalize the denominator by multiplying both sides by square root of 2. So, 1 times square root of 2 is square root of 2. And square root of 2 times square root of 2 is 2. Let us now get cosine of 45 degrees. Cosine is adjacent over hypotenuse. Adjacent side measures 1 unit and the hypotenuse is square root of 2. So, similarly, we multiply both sides by square root of 2 to rationalize our denominator. Therefore, we have square root of 2 over 2. If you can see, sine 45 degrees and cosine 45 degrees are equal because 45 degrees and 45 degrees are complement of one another. Therefore, its cofunctions are equal. Now, we will get tangent 45 degrees. Tangent is opposite over adjacent. So, 1 over 1, which is 1. So, when we get the cotangent or value of the cotangent 45 degrees, that is adjacent over opposite, which is also 1 over 1, and that is 1. When we get cosecant and secant, we will expect that both values are the same because they are cofunctions of complementary angles. Secant is hypotenuse over adjacent side, which is square root of 2 over 1, and that is simply square root of 2. And cosecant is hypotenuse over the opposite side, which is also square root of 2 over 1, which is square root of 2. So sine and cosine of 45 degrees are both square root of 2 over 2. Tangent and cotangent are both 1. Secant and cosecant are both square root of 2. Now let us move to the trigonometric ratios of 90-degree angle. Let us consider triangle ABC whose right angle is at Z. Side AC then approaches 0 and side BC approaches AB. Angle B gets closer to 0 degrees while theta gets closer to 90 degrees. Let's have sine 90, which is equal to opposite over hypotenuse. The side opposite the 90 degrees is BA, and the hypotenuse is also BA. Therefore, sine of 90 degrees is the hypotenuse over itself, and any number divided by itself is always 1. Now, let us get cosine of 90 degrees. Cosine is said to be adjacent over hypotenuse. The adjacent side is either BC or AC, which are both approaching 0. Therefore, cosine 90 degrees is 0 divided by the hypotenuse 1. 0 divided by 1 is still 0. Now, let us get tangent 90 degrees. Tangent is said to be opposite side over the adjacent side. The opposite side is the hypotenuse, which is BA, and we can use either of the adjacent sides, BC or AC. So let us just use AC, and we know that AC is approaching 0. The measure of BA or the hypotenuse is 1, and AC is approaching 0. Now, the value of tangent 90 increases without limits because its adjacent side approaches 0, and it is undefined because the definition requires division by 0, which is an operation that is undefined. So, we will be using the symbol lemniscate to represent a value or a quantity which is not finite. Now, let us get the reciprocal ratios for 90 degrees. The reciprocal of sine is cosecant. And cosecant is hypotenuse over the opposite side, which is also 1. Now, secant 90 is hypotenuse over the adjacent side, so that will be 1 divided by 0, which also give us the value that is undefined. Now, the reciprocal of tangent 90, which is cotangent 90, is equal to adjacent over opposite, so it's 0 divided by 1, which is 0. Included in the list are the trigonometric ratios of 0 degrees. Sine 0 is 0, cosine 0 is 1, tangent 0 is 0, cotangent 0 degrees is undefined, secant 0 degrees is 1, and cosecant 0 degrees is also undefined. For our next video, we will answer the following practice activities. For exercise 1, we are going to simplify the following expressions. 4 sine 30 degrees, 2 cosine 60 degrees squared, sine 30 degrees plus cosine 45 degrees, tangent squared 45 degrees plus tangent squared 60 degrees. For number 2, we are going to find the value of the unknown A given that the hypotenuse is 8 centimeters. For the next question, we are going to find the value of the unknown C given that the angle is 30 degrees and the hypotenuse is 16 centimeters. And for the last question, we are going to find the value of X. I hope you were able to learn a lot from this video. See you on the next video. Thank you, keep safe, and stay healthy.